Hi everyone, this is Jouni from Process, and in this presentation I will talk about data consistency with OPC UA. I'm concentrating on the client-server communication, where we have a few different options how the clients and servers can exchange data with each other. The clients are always calling the server, and there are a few service calls that they can use to request data from the server. The first one of them is read, which is very useful, for example, for parameter reads. The other option for monitoring changes in the server, data changes and events, is to create subscriptions and monitor items. And then the clients can use history read to read data that is recorded in the server. Clients can also update data in the server using write calls, especially for parameter updates, but it could be kind of anything. But there are also the other options to call methods, which are more useful when there is an action to be taken in the server, and then the server can also acknowledge if this action worked all right. Now, if we look at the connection management, so the topic that I'm concentrating here is how do we ensure that that these data changes are always happening properly, despite of interruptions in the communications, for example. And if we look at the connection management, the client-server communication is based on creating a session between the client and the server. And this includes authenticating the client application in the server, and then all the data exchange occurs over this authenticated session. The session has a timeout, so if the client disappears for some reason, the server can get rid of the resources reserved for this client. Over this session, the client can create subscriptions for these data changes and event notifications, and this enables buffering on the server, even in case of disruptions in the communications. So let's look at a basic example of sampling data in the server. The server starts sampling according to the instructions of the clients, meaning the client creates monitored items, and these define which variables it wants to be sampled on the server or which events it wants to monitor. And the server uses buffers to keep these samples in the server until it has managed to send them to the client. So in this example, the server gets one sample for the data that is being monitored, and then delivers this over a data change to the client application. Now, what happens if the connection breaks? All the service calls from the client will fail, and the subscription buffers start getting filled. So we get a new sample, but this doesn't manage to get sent to the client. We get another sample that doesn't manage to get sent to the client. But then eventually the connection is recovered, and the buffers can be preempted to the client, and then we can continue the sampling and delivering the data changes to the client, like in a normal situation should always happen. Now the problem here is that that we have this server-side buffering, but the buffers are limited. So it's likely that if the connection break is very long, some data will be dropped out. This may be crucial to your application, or it may be not. It may be enough for the client to be up to date with the current state of the server, but if you really require all the data changes to be delivered to the client, this may not be all right. The event notifications are also another issue, and there we have like a more or less defined that the buffering is unlimited, but of course we all know that there are always limits in these computer systems for memory reasons and so on. But anyways, in this case, the connection breaks again, and then the buffers start getting filled, and they can't be delivered to the client. And eventually, when the buffer is full and we get a new sample, that will be dropped out. And the worst case that can happen is that the subscription times out. It also has a timeout. So after that period without a connection, everything will be dropped from the server. It will clean all the resources because now it thinks that the client will no longer be there anymore. These buffers are all per client, and the client defines the length of the sampling buffering, but there are actually some buffers in the server side as well. And this is like a bit tricky to get really reliable. So what other options do we have? Well, luckily we have the history read that could also be used for buffering data changes and events. So these are server-side buffers in practice. Whenever we get new samples, they will be delivered to clients, but the server still keeps the samples in its own buffers if other clients need them. And if we get a connection break and new samples, they just keep fitting to the buffers. And the good thing here is that the buffers are typically much longer and can be much longer than in the subscription model, where the server has to keep separate buffers for each client. And now when the connection is reestablished, the next history read will succeed again, and those new samples will be sent to the client. But the server will still keep the samples also in its own buffer, the history, and they will be available for the other clients to be read out. So these are indeed shared by all clients, and enables long buffering. And you could say in that sense it's independent of longer timeouts. It's more or less dependent on the length of the buffering reserved for the server, and that defines the capabilities. If we consider service calls in relation to the communication breaks, this is especially important for the write and method calls that the client would use to update data in the server. If the connection break happens, these of course will fail to succeed. And we need to wait until the connection is recovered, and after that the service calls will succeed again. So the client just needs to keep retrying until the data is delivered to the server. So as a summary, OPC UA provides a really robust connection management, and the subscriptions in there enable server-side buffering, but they enable seamless recovering from short-term connection breaks. But for long-term connection breaks, we need history read practice. Write and method calls require retry after connection breaks, and that's more or less the responsibility just of the client applications. So with this short presentation, I hope that you get an idea of how OPC UA enables you to keep data consistent between different systems in your production. And hope to see you again in the next presentations.